Exercise for 1. Document 1 shows two cars, M and N, in rectilinear motions along the positive direction of the x-axis. At t0 equals 0, car M starts from rest at the origin O of the x-axis and moves with an acceleration of magnitude 2 meters per second squared. Given the time equation of N is x of N equal minus 0.8 t squared plus 30t. Okay, this is for N. Now, it is required in first part, phase 1, until M and N meet. We have the motion of car M. Write the time equation x of t and v of t of M. Okay, so x of t and v of t. You're given that M starts from rest at the origin, from rest, and moves with an acceleration of magnitude 2 meters per second squared. And here you are given indirectly that the motion, as long as it's also moving along a rectilinear path, as given here and as shown in the figure. So indirectly you are given that this is UARM. Okay, so 1.1, it is UARM, given that it's UARM, and you are supposed to find the time equation. You all know the position time equation, the general equation of the position time equation for UARM. It is x equal half at squared plus v0t plus x0, where v0 is the initial speed and x0 is the initial position. Okay, now let's check, where did M start moving from? It started moving from the origin, so the initial position is 0 here in this case, and it also started from rest, so the initial speed is 0. So we are left with the term x equal half at squared, and a is given to be 2 meters per second squared, so we have half times 2 times t squared. So x is equal to t squared. Now this is the general equation for M. So I can say that this is xm. Now v of t for M. Again, what is the general equation for UARM? It's v equal at plus v0. Okay, we have v0 because it started from rest is equal to 0 and a is 2, so v for M is equal to 2t. Okay, now 1.2, deduce the instant at which M reaches D, whose abscissa is x of d equal to 120 meters. Calculate the speed of M at this instant. Okay, you are given position and asked to find time, so for sure you have to refer to the position time equation, not to the speed time equation. So x of d equal to 120 meters, this means that xm now is gonna be also 220 meters because it's going to reach that position, so its position away from the origin will be equal to 220 meters. So now I substitute in the position time equation 220 meter is equal to t squared, okay, square root both sides, so we have t is equal to plus or minus radical 220. Plus or minus, this is mathematics, so in physics we can't have negative time or negative instant. Okay, so that's why we're going to exclude the negative value and accept only the positive value. So t is equal to radical 220. Using your calculator, you have it equal to 14.83 seconds. T is equal to, plus of course you choose the positive value, 14.83 seconds, as long as all the units are in SI unit. Now calculate the speed of M at this instant. So you have to go to the speed time equation. Okay, so this is one. Now we have to substitute this t at this instant. The object was moving at which speed? V at this instant is equal to 2 into only 14 point, if it's not clear. Okay, 14.83 seconds. And 2 is meter per, this 2 is for the acceleration, so it's meter per second squared. Now second and second cancel, we are left with meter per second unit wise, and value is, you have to multiply 14.83 times 2, 29.66. It's enough to take 2 decimal digits after the decimal point, so 29.66. okay,